Hello, viewers. In today's session, we are going to discuss an important form of indefinite integration, right? So, here in this class, we are going to evaluate this indefinite integral, which is of this form, right? So before moving further, let us quickly analyze this form of indefinite integration, in which the integrand is of this form q plus p cos x divided by p plus q cos x whole square, right, where p and q are some real numbers, right? So now see, here we have to evaluate this integral, and now if we compare these two integrals, then we can easily see that the value of p is 3 and the value of q is 7, right? So let us see how we can find out the integral of this function, and we'll consider the general method here. So let us consider this one, right? So whenever we come across with the integrals of this type, where see, here we have p and here also we have p, and here we have q and here also we have q, right? So we have q plus p cos x, and in the denominator, the numbers p and q are interchanged, and we have p plus q cosine x whole square, right? So we have to make an important substitution here. So let us take this substitution, that is t is equal to sine x divided by p plus q cos x, right? So whenever we come across with these type of integrals, we always take this substitution. So we should always remember this form of substitution while evaluating these kind of integrals, right? So here let us call this integral as I, and here we have p is equal to 3 and q is equal to 7. So our substitution in this case will take the form, that is t is equal to sine x, and in the denominator we have p plus q cos x, and here p is 3, so we have 3 plus 7 cos x, right? And we can also here visualize that this sin x is the derivative of this term, that is cos x, if we omit the negative sign, right? Because the derivative of cosine x is the negative sin x. So we can, for just for the sake of memorization, we can here visualize that this sin x is the derivative of cosine x excluding the negative sign, right? So now our substitution is t is equal to sine x over 3 plus 7 cos x. So let us differentiate both sides with respect to x. So we have dt over dx, and now here we have the quotient of two functions, right? So this function may be taken as u and this function may be taken as v. So here we'll make use of the quotient rule for differentiation, that is the derivative of u over v is given by v du over dx. Then we have u dv over dx divided by v square, right? So now we have u is equal to sine x, v is equal to 3 plus 7 cos x. So now we have 3 plus 7 cos x, and the derivative of u, that is sine x, is cosine x. Then we have here u, so u is sine x, and the derivative of 3 plus 7 cos x is minus 7 sine x, right? And in the denominator we have 3 plus 7 cos x whole square. So now we can simplify the numerator. So we have 3 cos x then we have 7 cos square x, and then a minus and minus multiplied together becomes plus, and we have 7 sine square x divided by 3 plus 7 cos x whole square, right? So now we can take this expression, and we have 3 cos x, and here we can take 7 common. So we have simply cos square x plus sine square x divided by 3 plus 7 cos x whole square, right? So this is 3 cos x, and this is the famous expression for the trigonometric identity, that is cos square theta plus sine square theta is 1. So here we have 7 times 1, because this expression is equal to 1. So we have 7 times 1 7, and here we have 3 plus 7 cos x whole square, right? So we have dt over dx is equal to this expression, and we can easily see that this is our integrand, right? So this is the integrand. So now we can write dt is equal to 3 cos x plus 7 divided by 3 plus 7 cos x whole square, and here we have dx. So now our integral it takes the form here, this entire expression, that is 7 plus 3 cos x divided by 3 plus 7 cos x whole square dx. This expression is equal to dt, right? So we have simply here dt. And the integral dt is simply t, and of course here we have the constant of integration as c. So now our integral I is equal to t plus c, where c is the constant of integration and t is the substitution, right? So we have introduced this substitution. So now I is equal to sine x divided by 3 plus 7 cos x plus c, right? So this is the required integral, or the indefinite integral of this function. So now let us form another problem with the help of this problem, right? Suppose we want to evaluate this integral, that is 0 to pi by 2, and we have 7 plus 3 cos x divided by 3 plus 7 cos x whole square dx, right? So then what we will do, we'll first find out the indefinite integral of this function as we have discussed over here, right? And the indefinite integral is given by sine x over 3 plus 7 cos x plus c. So since here we have to evaluate the definite integral, so we'll omit this constant of integration. So we'll simply write sine x over 3 plus 7 cos x, and the limits are from 0 to pi by 2. So when we take here pi by 2, so sine pi by 2, and then we have 3 plus 7 cos pi by 2, and then we have minus sine 0, then we'll take this lower limit, sine 0 over 3 plus 7 cos 0. So this is sine pi by 2 is 1 and cos pi by 2 is 0. So this term goes to 0. So here we have simply 3, and here sine 0 is 0. So this entire term disappears. So we have simply 1 over 3, right? So the value of this integral is given by 1 over 3. So viewers, whenever we have an integral of this type, then we'll always make this substitution, right? Sin x over p plus q cos x, and the value of this integral is always equal to sin x, because see, here we have sin x, and the term is 3 plus 7 cos x. So here we have p plus q cos x, right? And c is the constant of integration. So the value of this kind of integral is always equal to sine x over p plus q cos x plus c. So from this discussion, we can now easily write down the values of these two integrals directly with the help of this result, right? So in the first case, the value of p is square root of 3 and the value of q is square root of 2. So the value of this integral is sine x and divided by p plus q cos x. P is the square root of 3 and here we have root 2 cos x plus c. And in this case, the value of p is 5, the value of q is 8. So the direct value of this integral is sine x, and here we have 5 plus 8 cos x plus c.